Okay, hello all again, and welcome to this video lecture of Octave with Spice. So we are now in chapter 2, GNU Octave as calculator, and we are still continuing in the first section, simple calculations and variables. And now we're going to the part and variables. So here we are in the page 8, middle of it, and so we consider how so we introduce variables to our calculations. And of course, like most programming languages, GNU Octave can handle many different types of variables. So we have different types. And on these types, GNU Octave uses what is called weak typing. Weak typing means that we do not have to introduce or declare the variables in any way, like you have to do, for example, in Java or C, or in many, especially the older programming languages. So if you don't know what this means, I mean, then you are lucky. So don't worry about it. In this section, or basically in this course, in this section, we only consider numbers, basically real numbers. And in the next section, we can consider vectors and matrices. So everything is real. Octave can understand complex numbers very well also, but we have no need for those in this course, so we'll simply omit them. And also later in the course, we consider strings. So strings are just strings of characters, like names, and a little bit so-called struct, that is called structure type variables. And as far as I recall, I will not be using anything else in this course. So for the purpose of this section, the variables are simply numbers, real numbers. And how do you assign a variable? So let's look at the exercise 2.5 here on variables, and let us also open GNU Octave here and look at look this exercise, or sorry, example there. Again, Control L clears the screen, or console, or command window. So suppose we have 1/3, 1/3, and we want to assign this value for later use to a variable. Let's call it x. So this is very simple. I have x, and it will be 1 divided by 3. And I hit enter. So now it will echo back, tell me what Octave will tell me what it just did. So it define a variable x and put a value 0.333. Actually, there are more 3's in the precision, but it just shows it, this approximation for it. And so it is. And also you can see that here's a workspace. There is a name for x as a variable, class double, dimension 1 times 1. Okay. Don't have to care too much about this. All right. So we can also ask on the console which variables we have there. So we know that here in the workspace, but let's ask also who. So it says the variables visible from the current scope, answer x. So this is now slightly different than the answer here. The reason there is that I didn't open the Octave again here. I had a previous session there. So let me actually open a new session. So I'll just shut down Octave and start again. So you can shut down any way you like. For example, exit in the command window. So it will exit. And let's start it again. So find this kind of icon. And then in the console, so let's go through this example 2.5 again. So x equals 1 divided by 3. It gives me x is 0.3333 and so on. Here I can see the workspace. I have the variable x defined there, I can also ask who. It says the variables visible from the current scope are x, so there's only one variable called x that are defined. Alright, let's continue. So these are relatively simple exercises. So if you think that this is basically very easy, that's good. That's the way you should think about it. Don't worry, this course will get much more difficult very soon. So suppose we want to calculate 2 to the power 1 over 3. So now it's 2 to the power x, since x is defined. So this just says that we can use this x, so 2 to the power and x like this. And again, to get the hat, since it's some kind of combined key, so you have to press space to get the hat there. So 2 to the power x, and now it gives us answer is 2.1599. Let's hope that it's same as here. It is. Okay, not too complicated here. Now there is a minor point that I want to make. So what happened here is, in this assignment x equals whatever, it told me that x equals, yeah, whatever it is. But then I asked it to calculate x to the power 2, and now it said that ans equals whatever the solution of this is. And what happened here is that I didn't ask, so I asked Octave to calculate 2 to the power x, but I didn't tell Octave to store the result to any variable. Here I asked Octave to calculate, well, basically 1 over 3 and store the result to the variable x, which it did. Here in this case, since I didn't ask Octave to store the result to any specific variable, it will use a so-called temporary variable or standard variable or standard answer, whatever you want to call it, ans. And it will calculate this result and store the answer to, well, this variable called ans. And now you can see, for example, here in the workspace that there are ans and x. Also you can ask who is there, who are the variables, and it will answer that there are two variables, ans and x. So this ans variable is the variable where the latest calculation that has been calculated is assigned to, unless we have asked to assign the solution for the latest calculation to some other variable. Okay. So this is basically, well, let's do this discussion here also. So as you can see, if I type ans, so if I just type a variable name, any variable name, in the console, what the Octave will do, it will echo back the value of that variable. So if I hit enter, it will give you that ans is what it is. Of course, if I ask for x, it will give the answer. Okay, this is not in the notes, but let's ask, say, y. Now this is, we get an error message. So if we had y as a variable defined, then it would have given us y equals whatever it is. But now it's not there, and what the Octave tries to understand why, well, it says error y undefined near line 1 colon 1. So it basically says that it doesn't know what y is. All right. So let's introduce some other useful commands using the command window. So we have this ans and some other also. So this is the example 2.7. Again, there is nothing too complicated here, just to introduce some useful commands. So first here is this CLC, basically means clear console. Okay, I have used this already. I've used it as a Control L, but let's see how it works. So this is another possibility to clear this clutter that you have on the screen. So CLC means that clear console. Okay, so now I have an empty screen, which is sometimes nice. You don't want to see all the clutters from the previous calculations. Let's then follow what is here. So let's ask who, which are the variables there. Of course, if you use the console this way, that you have the workspace window here, you don't have to do this. You can see them immediately there. But let's do this anyway, because I must say when I want to work with Octave, I usually these windows. So this is the working directory contents, and this is the numbers, the workspace, and here is the command history, that the commands that I've given. As you can probably see, I usually actually just remove these. I don't care to have them. Now I have left them there, at least so far, since this is probably the view you will have. The view I like to use is very different actually than the standard one. Okay, in any case, so here is the who. So the variables visible from the current scope, so basically variables that are defined there are ans and x. Okay, sorry about that. So they are the same. Now comes a new command, clear. So the idea is that sometimes these ans and x, especially if you work long, you will tend up to have lots and lots of variables there, and you don't maybe want that. One reason is of course that they take up memory. Usually that's not a problem, but then you have maybe you want to define, well, you can redefine them also. That's not a problem. They sometimes cause confusion, that you have forgotten you have defined already something to be something, and it can easily lead into errors. So every now and then you want to clear your workspace. So this means you want to remove these variables, and this happens with obviously with clear command. Okay, now it seemed that nothing happened because there was just this. We get the next prompt and nothing happened here. But of course, if you have this workspace window here, you notice that it was cleared, so nothing is there anymore. Or you can also do as we do here. We ask who. Okay, again, it seems that nothing happened. Well, this is the Octave's, well, what we get an empty answer, so to say. So if there is something in the workspace, it says variables visible from the current scope are ans and x, and now for some reasons those who implemented this Octave, I think this is compatible with the MATLAB working also, that if you ask who and there are no variables, you get an empty answer. Maybe it would have been more convenient that it would give you that there are no variables or something like that, but this is, well, that's the way it works, and that's the way it is. That's it. So who gave us nothing, and we can also let's go through what we have here. So x again, so we can now ask x. We get the same kind of error message as previously, so x is undefined because we just cleared all the variables ans and x. So what then? Well, now we can define them again. So let's take x to be 1/3 as in previous, and then let's take y to be 2 to the power x. So that was the same thing as before, except that then we didn't assign this value to the power x to anything. But now it's assigned there, and then we can ask who. So there are x and y. So this is pretty much the same thing that we had in the previous example, except that now we assigned the value y, or to the power x calculation, we assigned the answer to the variable y. And since we have already, so we have assigned some, when we do calculations, we have assigned the solution to a variable, so the standard answer was not used, so that's not defined. Okay, this is a minor point, but worth emphasizing. Then a final point And this is this example 2.8, and which I called shut up semicolon. And you have probably noticed, especially in this example 2.7, that Octave echoes back almost everything we do. So for example here, we said that x equals 1 over 3. Well, let's do it again. So it will tell us that x equals, yes, 1 over 3. Sometimes we want that, but later you will learn that it's getting annoying. That Octave always tells us back what just happened. I mean, we don't really want to know it all the time, or to see it all the time. And this is what is called a shut up semicolon. So you have probably learned the semicolon. I mean, if you have program with Java or C, or pretty much, well, in many programming languages, you have to end a line or actually an assignment with a semicolon. And then you have the problems that your code is not working because you are missing semicolon somewhere. This is the classical thing in at least in Java and C and many other programming languages also. So this is not the case with Octave. So you don't have to end lines with semicolon, but you actually do it quite often. And what is the reason? So let us do this example 2.8 of the Octave console. So first, let us clear the console. Then let us clear also the workspace. So the x and y from here, they disappeared. Good. So now we have a clear table, so to say. So no variables under the table and on the table or the console. There's nothing. Okay. We started fresh basically. Then I define, again, the x and y will be the same as in previous examples. They could be different also, but let's have the same. So let's have x equals 1 over 3, but now I put a semicolon there in the end. And now in console it kind of seems that nothing happened. Of course, if you look at the windows here, we saw that something happened. Let's do the same for y. So the y for the 2 to the power x, and again I put a semicolon at the end. Again, if I only look at the console, it seems that nothing happened. Okay, but something actually happened, and let's ask this who. So we see that they are actually variables x and y. They are defined. So x and y were defined here, and they were really defined, except that this semicolon meant that please be quiet. So Octave was quiet, so it quietly just assigned the value 1 over 3 to the x, and here the same thing because there was semicolon in the end. So the 2 to the power x value was assigned to y in all nice blissful quietness. And then I can ask for the variables. I can just type x, I get the value of x, and y, I get the value of y. Okay, I can do them in one line also if I put comma in between, then these assignments x and y are executed in a row. So it's the same. I can write it this way also. Okay, so the main and pretty much the only point here is this shut up semicolon. This will be useful. So the semicolon does not mean the end of line here in Octave, but it means that the previous thing will be performed quietly. Okay, so this is pretty much the general stuff I want to say about variables. There is one final note before we go in the next lecture about matrices and vectors, is that this is a word of warning. So what kind of names? So we have now given names x and y only these variables. Of course, you can use many more complicated names. They can be very long. They can be very descriptive. But there are certain well, restrictions and certain things that you are asking for problems if you do so. So about these names, so what kind of names of variables and actually also files and so on can have. So first thing, this is something that it's for the Windows users only basically. GNU Octave is case sensitive. I mean, big X and small x are not the same. I mean, the only system that I know that is not case sensitive is some Windows systems, and all other systems are case sensitive. So whether you have a variable named small x or capital X, they are not the same. And then there are what kind of names you can give to variables, or anything basically. To be completely honest, I don't know the exact restrictions. We can find them out, but that's more or less pointless because there could be a mistake in the documentation. There is a general rule that usually works. So do not start the name with a number. So don't have a variable like 1x. And then do not use non-English letters or characters like the Nordic ä or the Danish ö, or some weird characters with the sedals or circumflexes. Don't use them. Maybe they work, maybe they don't, but you should. I recommend you not to use them. Also, do not use spaces in the names. This is, again, probably you can do it in some way, but you are asking for problems. And don't use any special characters, like obviously don't use colons or semicolons or signs. That will not work. There is a major exception. So the underscore character, that you can use, and it is even quite often used as a replacement for a space, since the spaces are not used, or sometimes it is used as to denote the subscript. This is how we use it actually. We use it actually in both conventions in this course. Okay, this is again a minor point, but something that I have noticed that you will many students make the well it's not a mistake. It's kind of don't realize that you shouldn't use for example like the Nordic letters in the names, and then you have problems, and which is just comes from this, but sometimes it's not clear that this is the reason. Okay, thank you for listening. So this was the Octave with Spice chapter 2. Let us look at the contents now, so we'll see where we are. So chapter 2, GNU Octave as calculator. So now we have studied simple calculations and how variables works, and learned a little bit how to work with console. So the next lecture, video lecture, will be about, or couple of next lectures will be about matrices and vectors and how they are used with GNU Octave. See you in next lectures. Bye.